other system components, that is watchdog timer. This is also an additional circuit. So the name itself tells that it is watchdog. So it is watching. So it is actually the circuit is watching the computer operation. So this watchdog timer is actually an electronic timer that is used to detect and recover from computer malfunction. So this continuously monitors whether the system is functioning properly or not. So we will see how exactly it monitors and how it is going to recover. So during the normal operation, the computer regularly resets the watchdog timer to prevent it from elapsing. So this is an additional circuit. So the computer now and then it will be resetting this watchdog timer. So that when once it resets, the watchdog timer will understand that the computer is functioning properly. So we will take an example and we will see that. So every time the computer resets, every time in a sense, there will be a time duration. With that, it will reset, and that is a confirmation to the watchdog timer that yes, system is functioning. If due to a hardware fault or program error, the computer fails to reset, somewhere the system is getting hacked, it cannot, it is not under its own control. In that case, it fails to reset the watchdog timer. So, for example, assume for every 30 minutes, the system is resetting the watchdog timer. But if 30 minutes has elapsed and still the processor has not reset the watchdog timer, means it is clearly understood that there is a malfunction. So, immediately it will generate a timeout signal. Now, let's go to the next slide. Now, the timeout signal, what it does, it is used to initiate the corrective action. Now, what is the corrective action? It will make the computer system to turn it into a safe state, safe mode, or restore it into normal system operation. So, depending on the internal implementation, the watchdog timer increments or decrements. So here I have told you that watchdog timer makes use of a counter. Now we can either increment the counter or you can decrement the counter. So we will see how it is. It generates a reset signal to reset the processor if the count reaches 0 for a down counting or the highest value for an up counting. So for example, if the watchdog timer is following the up counting system, means now it is 0. Initially, the computer will make it as 0, and the maximum target is 30 minutes. So the counter keeps incrementing 0, 1, 2, 3, 4 like that. So before it reaches 30, the computer will reset the watchdog timer once again. Maybe somewhere nearing 29, or even 30. It has to reset. Suppose it doesn't reset, it will understand as a malfunction and it will convert it to the safe mode. So this is an up counter. Once it is nearing to 29, suppose if the computer is perfectly fine, there is no malfunction. What it does, the counter has reached to 28 or 29 or even 30, it will make that again 0. So once again it will start from 0, 1, 2, 3. Again the computer will reset for the next 30 minutes. So within the next 30 minutes it will reset. So it is like if the counter goes 0, 1, 2, 3, it is an up counter. Now, if it is down counting, then assume it is first it will reset the time, that is like 30 minutes. So 30, 29, 28. So till it becomes 0, okay, before it reaches 0, the computer will reset. And here reset back again to 30 minutes. Again, it will start incrementing 30, 29, 28. So once it is nearing to 0, if even if it has reached 0, still it has not reset the value, then again it will understand that there is a malfunction and it will continue. It will convert that system into a safe mode. This is how the watchdog timer works. So now let us go to the next slide. So the same example, whatever I have told, if the watchdog counter is in the enable state, the firmware can write a 0 in case of up counting. So before you start the execution of the piece of code, maybe before it starts executing anything, it will just make the counter as 0, and the watchdog will start counting. If the firmware execution doesn't complete, that's what as I said, somewhere it is executing some program, it gets stuck. Due call function within the time required by the watchdog to reach the maximum count, then the counter will generate a reset pulse. So reset, all of you know. So it is going to restart the computer from the beginning. So this is how exactly the system works. Now let's go. Let's see how it is in the next slide. So now you're seeing in the left hand side a watchdog circuit. It's the 3 running counter, and right hand side you're seeing a microprocessor. You're seeing here watchdog to microprocessor. So watchdog is actually connected to a reset pin. So usually the reset pin, to reset pin you have a reset circuit, you have a watchdog circuit, and even brownout circuit. So all of them, they will be connected to the reset pin. So there will be one more circuit to handle all these things to the reset pin. So depending upon from where it is coming, that corresponding interrupt is generated and the controller will behave accordingly. Next, you are seeing from the microprocessor to the watchdog, you are seeing there is a watchdog reset. So understand, I hope you're getting it. So microprocessor or controller, it may reset this counter value. To control all these things, you are having a system clock. So this is how the communication happens. Let's go to the next slide. Now, most of the processors implement watchdog as a built-in component and provide status register to control the watchdog timer. Whatever I have shown you in the previous slide, it is not an inbuilt, it is an external component. But some processors may implement watchdog internally, and what it can do, it can provide a status register to control the watchdog timer. So all of you know the status register. So you have come across already, and each bit in the status register performs a certain task. So here also, here you can have a status register, and the status register one bit you can make it to control watchdog timer. So this is possible if you are making the watchdog timer inbuilt inside the processor itself. So and watchdog timer register for writing the count value. So using one status register and the watchdog timer register with these two registers, you can have an inbuilt processor and you can perform the same operation. Suppose if the processor doesn't contain a built-in, as we saw in the previous slide, the same can be implemented using an external watchdog timer IC circuit. Means you can have an external circuit and you can make it to connect to the microprocessor or microcontroller. So here, for every example, we are taking microprocessor or microcontroller. Means it is used in the desktop systems, laptop systems, and all that inbuilt. Or you can also use this in the embedded applications. Not all embedded applications uses the watchdog timers. There will be some critical applications wherein this watchdog timers are required. For that purpose, you can go for watchdog timer, usually where the human control is not there. Something like you have a satellite and it has satellites and there are so many embedded systems inside that, and somewhere something goes wrong, it has to recover by itself. So such kind of applications you can go for watchdog timer. Otherwise, manually in our lab, suppose anything happens, what we do, we will manually reset it. So that you can just do with the reset pin itself, reset switch itself. So in applications like what I said, like satellites, where somewhere like components are and you cannot have control over that, in that case it has to self-rectify. For such purpose, for those type of applications, you can make use of watchdog timer. So